Topic, converting between logarithmic and exponential equations. I call this the log dance. And what we're doing is we're using the concept of what an inverse does. An inverse undoes what the original function does. So what we're going to do is we're going to use the basic thing. If we've got a logarithm with some base, and I'll do it with shapes. So I'll do a triangle down. So we got some number down here as the base of a logarithm. So in this case, it's a 3. Then we have an input into the logarithm. We'll do that with a square. Okay, so a location, whatever's there, and it's equal to some sort of an output. We'll do that with a circle. Maybe make a smiley. That's not really a 0, but let's make it a smiley face. There we go. So you've got these 3 things, and when the conversion from logarithmic to exponential function, what happens is these things change places. So in inverse, so notice there's sort of like 2 operators here. There's this triangle and the square. These 2 are together operating on it, and they produce this smiley face. What we're going to do is the exponential will change the order. So these 2 items, the triangle and the square, will not be together. The triangle is always going to be the base of the exponential. That means there's going to be an exponent on this triangle. The exponent can't be the square. It's got to be the other part. So this smiley face now becomes the exponent, and the square becomes the output. So notice how we had 3 items, and I got out of the numbers. We're going to see it applied here. The thing is this is a 2-way process. If I've got an exponential, I can turn it into a logarithm by going the opposite way. So let's see if this makes any sense to you as we apply it to numbers, but thinking in terms of we're just really highlighting spaces, really, right? So for this one, the A part, log base 3 of 81 equals 4. So we have, obvious it's already a logarithm. We want to turn it into an exponential. Thing we see here is that the 3 is our base. So that's going to be here, and it's going to have an exponent on it. The exponent has to be the thing that it's not already together with, right? It's 3, 81. These 2 numbers are together. They're not going to be together in the inverse. So the 4 is what the exponent's going to be. And I find with the logarithms, if you always focus on the base part, everything else comes together. So the 4 has to go with it, and that means it has to be equal to 81. If you plug this in a calculator, 3 to the 4th power, you get 81. If you would have done it in another way, say 3 to the 81 equals 4, you'll see that doesn't mathematically compute. It's not correct, but this is correct. Okay. And now if we go rewrite as a logarithmic, so we've given an exponential, notice it's really going to follow the same pattern, but what it is we're starting on this side. So we've got an exponential, we got a base, we got an exponent. And so what you'll see is the base and the exponent, the 8 and the -2, they're going to be on opposite sides of the equal sign now, right? 8 is our base, so let's make that. It's going to be log base 8. The base is always the base. What goes inside the logarithm? The thing it's not currently with. So 8 and -2 have to split sides, so that leaves, that 1/64 has to come here. And then where does that exponent goes? It goes to the other side, right? The smiley face comes to the other side, -2. It's just a matter of moving things. We didn't calculate anything. We just located items where they needed to be. These are our final answers. So let's go ahead and put those in there. And nothing on these one, we don't have to simplify. We don't have to, what is 1/64? Does that have to turn into a decimal? No, leave it exactly as it is. We've got a fraction tool here. So we put in 3 raised to the 4th power equals 81. And I call it a dance because you're just moving, right? They're kind of moving locations. They're dancing. Log base 8 of 1 over 64. Now, should we put a parentheses around it? You could, but they don't give them to us, so I don't know if we can. Let's see. No, it won't let us put a parentheses anyway. So, but there should be. But hey, we'll get by in a -2 there. So we've done the log dance. We've got things in their proper places. This is all we need to do with this question. Thanks.